All right, kiddos. Well, here we are. We talked about that this could happen, and well, here it is. So we're gonna do some online learning. And again, we're still talking about wind and weather. We're gonna review a couple of things before we start with anything new, and then we will move on after that. Again, latitude and longitude. Latitude and longitude. Remember, longitude lines run vertically. It looks a little bit like this. Maybe. There we go. It's these lines that run like this. Now, we said that longitude lines are important, but I don't think that they are as important as the lines of latitude that we talked about. Now, you need longitude and latitude in order to get very specific as to where you are in location on the world, and the lines of longitude do have value. But for us, the big thing that we need to worry about is the lines of latitude, because even if we were to look at us living on, let's say we lived on this line, we would have to live on a very specific spot on that line, and that's where latitude falls into place. So living on that specific line of longitude wouldn't specifically give me a lot of information. It'd give me a little bit as to my location on the Earth, but it really wouldn't give me a lot of specifics. However, when we looked at the lines of latitude, those lines that run vertically, horizontally, we know that those are very, very important. Lines of latitude run horizontally. And those are the ones that give us very specific, detailed information about what our climate might be like on Earth, because that looks a little bit more like this. These lines are very important. For example, if we lived here, we all know that that line of latitude would be called the equator. And we learned back with ecosystems that that's where it stays pretty much warm and hot all year long, very humid. That's where a lot of our rainforests are located. And living on that very specific line of latitude is important. However, if we were to live, well, that one's hard to see, but up here on this one, or way down here, there's not even one there, but I'm going to make one here. We know that it would be very cold because of the way the Earth is tilted. Those aren't getting very direct sunlight, and it's actually pretty cold there. So the lines of latitude as we come down and in the middle there are very, very, very important. Back to our slides. I had to skip through a bunch of stuff. This is where we stopped in class. It was time for us to move on Friday. And we're going to talk about air temperature. This is nothing new. This is something we've been talking about for a while, and this goes all the way back to when we talked about heating up and cooling things down. We know that the hotter something is, the more the molecules are moving around very quickly, and that the cooler something becomes, the molecules are moving, but they might start moving a little bit closer together. And right here is a fantastic example of what those molecules might look like. Cold air, therefore, because it has more molecules close together, is more dense. This is because the molecules are super close together. It's important to understand that. And I think that might help you understand why cold air sinks. Why cold air sinks. Again, that is nothing new. We did the experiment in class with the convection cell, but we were using water. We had hot water and cold water. And you can remember, you could see the hot water rising and the cold water sinking inside of that experiment. Hot air, again, looking at the amount of molecules, makes sense that it's less dense. And that's because as air heats up, those molecules start to move faster and they start to get further and further apart. And because of that, that is one of the reasons why hot air rises and why cold air sinks. Very important for us to remember. I told you that convection cells will be coming back, and well, here they are. Humidity. We've talked about the hygrometer. We talked about how the hygrometer measures humidity, and we even got into what humidity is a little bit. But make it super official now. Humidity is the amount of moisture in the air. When you add moisture to the air, it adds density to the air. As you see here, it adds density to the air because water vapor molecules are also now taking up some of that space in the air. We know what a humid day is like. If we look back to a couple of days ago when we were outside, it was beautiful, super sunshiny. We were all outside for a long time. It was a nice, cool day. High pressure, by the way. And we all enjoyed it. However, the last day we were in class, it was unbearably humid. There were lots of clouds in the sky, and we could feel it. I mean, we were sweating in class. That's why we had the fans on. We had the windows open to get some air moving around. It was just a pretty humid day altogether, and that's because there was more moisture in the air. And so let's move on from humidity, not forgetting that the hygrometer measures that. That's something that will always come back. Updrafts and downdrafts. I think this is pretty easy, but the sun is going to heat up the earth. We've talked about that. And when the sun heats up the earth, hot air rises. Well, if you look here, you see hot air rises. Again, science, they don't like having just one term. They don't want to say hot air rises. They're going to start calling that an updraft. An updraft. Now, that's pretty easy. That is a draft of air that's moving upward. Hot air rises. Updraft. However, if you have an updraft here, you know that somewhere over here, cold air is going to sink, because we know we are continuously having those convection cells in the air. And when cold air sinks, that's good that we know that. Another way that we're going to say that is we're going to call that a downdraft. A downdraft. So we have hot air rising, updraft, cold air sinking, downdraft. If we need to, we can draw that really quickly. So we can have hot air rising over here, cold air sinking, and we can label those as, that's giant text. Oh my. Here we go. And we'll come over here. Man, is it weird not having you in class. Holy cow. Do not like this. I miss all of you. But there's updraft and there's downdraft. So I'll give people a few seconds to jot that down, or I guess you could pause the video. So I will continue to move on here and go back to our slide. So updraft and downdraft, that's going to start playing a very important role in a lot of the things that we're about to learn about, especially when we get to sea breeze and land breeze, mountain breeze and valley breeze. Understanding updrafts and downdrafts is going to be vital. That brings us to the subject of wind. Again, I think that's one of our vocabulary words. The horizontal movement of air is wind. And air likes to move from high pressure to low pressure. And there's a very simple way to show that. If we take a balloon, we blow the balloon up. We know that inside of here is higher pressure. We can actually feel it, right? And when you blow a balloon up too much, you really understand that there's pressure in there. However, it's no secret to anybody that when I let this go, that the air is going to move from inside of here outside, because that's the way that air likes to move. It moves from areas of high pressure to areas of low pressure. And we call that wind. Air pressure differences come from the unequal heating of the Earth's surface. This is a spot where I would most definitely pause the video and jot that down. It's one of those things that you're going to see over and over and over again. The reason why we have high pressure, the reason why we have low pressure, is because the Earth is heated up differently in different places. That starts all of the different global winds that we are about to talk about here very, very soon. So just understanding that the unequal heating of the Earth's surface is the reason why we have differences in air pressure, and because we have differences in air pressure, that's why we have global winds. Skip that, skip that. You can do that at home. How are winds formed? We literally just said this. It starts with the sun's radiation. The sun starts to heat up the Earth. Because the Earth is tilted and you have different parts of the Earth heating up differently, you get differences in air pressure. And when you have differences in air pressure, air moves from areas of high pressure to low pressure, just like we had when we were doing the balloon. And because there's such a giant difference in the pressures around the Earth, we're going to end up with some things called global winds. But even local winds are made in the exact same way. You're going to have different areas, even locally, that are heated differently during the day. And because of that, you're going to have different atmospheric pressures, and therefore you're going to have some winds. Again, air above surfaces with cooler temperatures do not rise. The air here sinks. We know that because hot air rises and cold air sinks. Down here, warm gases are being replaced by cooler. This is called convection. We talked about that when we had convection to begin with, that convection wasn't going anywhere, and that convection was still going to be around all the time. So it's something that we can't forget. That convection cell is going to play a role in weather from here for a pretty good while. We're going to be talking about convection cells. So don't forget about those convection cells, or you might hear it called as a convection current. I'm going to stop this portion of the video here because we are soon going to get into something called global winds. And because there are so many different types of global winds, especially one that's very, very important to us, and I know that I'm going to spend a giant amount of time on that, I want to stop this video here. Go ahead and get that uploaded to YouTube so you can at least do one part of that for today, and then we will move on to the global winds as we keep on moving.